This is the first video in the volume series. Today we're going to look at volumes of prisms and cylinders, but first I want to talk about volume. Volume is a three-dimensional measure, one of length, width, and height. And basically, how we're going to find volume for most of these shapes is that we are going to find the area of a base. For example, this prism has a base, and then we're just going to simply count how high it is stacked, the height. And we're going to multiply that, and that's going to tell us our volume. So let's go to the first page here and look at the formula. Just as I described, we're going to multiply the area of the base, that's what big B stands for, times the height. So the key is just identifying the base, and remember the base means parallel sides. So you have more than one choice sometimes. Typically we'll choose the bottom, making sure that the bottom is parallel with the top. If that is not the case, then you cannot use the bottom as the base. But this is, we have a rectangle, so it's 10 times 4, the area of the base is 40. And then the height is the distance between those two things, which is 6. So volume will equal 40 times 6, which equals 240. And since we are in meters, it is cubic meters. I'll leave you to try number 2. Has a very similar method here. You can consider your base to be this bottom part, 3 by 6. I want to look at some things that are not going to be quite as obvious. The right triangular prism here, our base we can't choose as the bottom because that's going to not match up with the top. They're not going to be parallel. So rather we have to choose the front and the back as triangles. So the area of the base will equal 1/2. Triangle is 3 times the height, which is 1, so that's 1.5. And then we multiply the distance between those two, which is 2, so it's 1.5 times 2. The volume is 3 cubic feet. All right, one more example. Here's a swimming pool. Again, we can't use the bottom because this bottom and this top are not parallel. So we have to use the front and the back. This front is a trapezoid. The back is a congruent and parallel trapezoid. So we need to find the area of that. Base, area of the base is 1/2. The height, it would be this distance here, which is going to be 36. The two bases together are 12 plus 18. And that area will be 540. We're going to multiply by the distance between those two bases, which in this example will be 18. So the volume will equal 540 times 18, which is equal to 9,720 cubic feet. All right, so anytime you have a cylinder, a prism or a cylinder, you're basically going to be multiplying the area of the base times the height. And when we move on to cylinders, we actually can get even more specific because a cylinder always has a base of a circle. See, with a prism, you could have a triangle, a trapezoid, or a rectangle, as you saw before. But with the volume of a cylinder, it's always a circle. So we can find big B, but really we can use this more specific formula. Volume equals pi times the radius squared. All right, this would be the big B, and we would multiply by the height, which is 5. And we just type that into our calculators. Pi times 4 squared times 5 is equal to 251.3. And again, cubic meters. Number two, we just need to be careful that we use the volume formula correctly. Again, I'll write it pi r squared times the height. The radius in this situation, we need to cut that diameter in half, so the radius is 8. So volume equals pi 8 squared times the height, which is 21. Type it all into your calculator. Pi 8 squared times 21. 4,222.3. And here we don't have units, so the units will just be cubic units. I'd like you to try number 3, see if you can find the volume of that Campbell's soup can on your own, and you can check your work with the completed notes.